In this problem, we need to find all the zeros of this fourth degree polynomial function. But we're given a big hint. We know that -3 is one of the zeros. We just have to find the other ones. So what does that mean if I know that x equals -3 is a zero? Remember, that means that x plus 3 is a factor of my polynomial f of x. And what that means is if I divide x plus 3 into f of x, I should get a zero remainder, and I'll also get a cubic equation that might be easier to solve. So that's our first step. We could divide using long division, but since it's in the form of x plus a number, we can use synthetic division, which is a whole lot easier. Don't forget, we have to make sure there are no missing terms in f of x. Well, it goes x to the fourth, x cubed, x squared, x, and a constant. There are no missing terms. So now I'm going to do my synthetic division. And remember, the number you put in the box is the zero, not the number that's with the factor. It is this number here. And then I'm just going to strip off my coefficients. 1, 2, -8, -10, and 15. So I just put 1, I put 1, 2, -8, -10, and 15. And now we're ready to do our synthetic division. Remember, the first number you bring down as is. Then we're going to multiply -3 times 1, which is -3, and we're going to write the answer here. Then what do we do? Add these two numbers. What's 2 minus 3? It's -1. Then I'm going to repeat the process. -3 times -1 is +3. And then I'm going to add -8 and 3, and I get -5. I'm not going to draw any more arrows. It's going to get too confusing. What's -3 times -5? +15. What is -10 plus 15? It is +5. And the last step, what's -3 times 5? It is -15. What's 15 minus 15? It is 0. Good. That confirms that -3 is a 0 because I got a 0 remainder. So what this means is f of x can be written in partially factored form. I know that x plus 3 is a factor. And what's the remaining polynomial going to look like? Remember, I started with a degree 4. This is a degree 4. This is going to be a degree 3. So this is going to be x cubed and x squared, x and constant. So I'm going to get x cubed minus 1x squared, or just minus x squared, minus 5x, and the last term plus 5. So now, using that first 0, I now have a cubic polynomial here, which should be easier to factor. And since there are 4 terms in this, we could try factoring by grouping. And in fact, this polynomial will factor by grouping, but I want to show you what you do if it won't factor by grouping. So now we look at this polynomial, and we're going to set that polynomial equal to 0. And what we're going to do is we're going to find all the possible rational zeros. And remember, the way to find that is factors of the constant term, which is 5. So it's going to be factors of 5 divided by factors of the leading coefficient, which is 1. So there aren't too many possible rational zeros. factors of 5, it's just plus or minus 1 and plus or minus 5. The only factors of 1 are plus or minus 1. So I only have 4 possible rational zeros. And what you're going to do is you're going to do synthetic division until you find one that gives you a remainder of 0. So I'm going to use, the first one I'm going to try, I always try first, is positive 1. I'm using this polynomial, not my original one. So I look at this one, no missing terms. So my coefficients are 1, -1, -5, and 5. So 1, -1, -5, and 5. And let's see if synthetic division works. Bring down the 1. 1 times 1 is 1. What is -1 and 0? It is, what is -1 and 1? I already told the answer, it's 0. Then you do 1 times 0 is 0. -5 plus 0. Remember, add these two numbers and you get -5. Last one, 1 times -5 is -5. What's -5 plus 5? 0. So did I get a remainder of 0? Yes. So I know that x equals 1 is another 0. And what is my resulting polynomial? Well, let's see if we can write a polynomial in factored form. So I have f of x equals, I know it's x plus 3 times, what's the factor that goes with x equals 1? Remember, it's x minus 1. And what's my last polynomial? What is the quotient here? Remember, this was x cubed. So this is x squared. So I have 1x squared, I have no x's, and I have minus 5. So I'm just going to have x squared minus 5. So now I've got it in factored form. This is not the difference of two squares. It won't factor. So I'm going to set x squared minus 5 equal to 0. Add 5 to both sides. And then just take square roots of both sides. So I land up with x equals plus or minus, don't forget your plus or minus, the square root of 5. So what are my other zeros that I found? I found x equals 1, x equals plus or minus 5, and don't forget we were given the original zeros of -3. But remember, if you get a problem that lands up with an x term in here, you're going to land up with a quadratic here that you'll either be able to factor, or if it won't factor, use the quadratic formula. However, in this problem, don't forget this could have been solved by factoring by grouping. So let's quickly do it to prove we get the same answers. So factoring by grouping, group the first two, group the last two. What do the first two have in common? I think it's x squared. And if I factor an x squared out of an x cubed minus x squared, it's going to leave me with x minus 1. And when you factor by grouping, don't forget you always want to use the middle sign, So you're going to factor out a negative, but a negative what? What do these two have in common? 5. So be careful when you factor a -5 out of -5x, it's going to leave you with x. And what happens when you factor a -5 out of a +5? It's going to leave a -1 behind. If you're not sure, just distribute that back into here to see if you land up with those terms. So now did factoring by grouping work? Is this the same as this? Yes, it's your common binomial factor. And what does it leave behind? X squared minus 5. So do I have exactly the same as I had down here? Yes, so you get the same answer both ways.